So we are basically going to look at 7 possible motions with constant accelerations. Start drawing x versus t graph versus t and a versus t graphs. This is x versus t, and this one is v versus t, and the next is a versus t. Now we are going to mark these 7 motions, possible motions, on this graph. First one is to the positive direction. First one is increasing speed for the positive direction. Think about you left home, come into the college, and all what you do is first get on your car or bike. You increase the speed. Now your direction is from home to college. Positive direction. Speed is increasing. Corresponding velocity graph is increasing speed. On x versus t it was parabolic, but on v versus t it is linear line. When we calculate the slope of this linear line, corresponding v versus t graph can be found taking small steps on x versus t and calculating the slopes of these lines, which I will come back to it later. And that's going to be a linear line like this. The same way, if we take the slope of this linear line on v versus t, and that's going to be a constant on a versus t, acceleration versus t. So this is speeding up or increasing speed. Then after you increase your speed, on the way you keep your maximum but constant speed all the way to the college. It is like this. It is a linear line now on x versus t graph. And now let's apply the same rule to go to v versus t. We need the slope calculation here. The slope of this line on x versus t is going to be a constant number on v versus t. Constant number like this. Now slope of this constant line on v versus t is going to be 0. Okay, next is now you are almost at the college. You are going to slow down and stop. So slow down to stop is this on x versus t. That means while you are still slowing down, your vehicle is still moving forward. That's why you are still moving away from home. This was home. You are still moving while slowing down until your vehicle completely stops. We can see this on v versus t graph better. Your speed is now going from a higher positive number to back to 0. 0 means no speed. It's completely stopped. Now applying the rule once again, calculating slope on v versus t, which is a negative slope. That's going to be marked as a negative number like this on a versus t. Beginning to the end, the vehicle was moving to the positive direction. That means from home to college is taken to be positive direction. Next is no motion. So that means you are stationary at some time. It means you are sitting and listening to the lecture. And the slope of this line now on x versus t is 0. And we mark this as 0 like that. And this 0 line has no slope, and that's going to also be marked on a versus t as 0. So this is a stationary portion of the 7 possible motions. Now the day is over. You need to go back home. Now you reverse the direction from college to home. Once again, from this point to this point is all positive direction motion. During this time there is no motion, stationary. Now you reverse your direction to go back home. Speed up to the negative direction. This line shows that all individual slopes on this line is an increasing negative value, and slope of this line on VT graph is another negative acceleration, which we are going to mark it as negative value. Same as slowing down. This is slowing down to the positive direction, which was negative acceleration. Once you speed up to get to a maximum speed, and you continue with that speed all the way to home, a linear line is also shown on x versus t graph. Slope of this linear line is a constant value on v versus t. This constant line has no slope, so we are going to mark this as 0 on a versus t. And lastly, you are almost home, so you are going to slow down to stop. This is how to slow down to stop. It's another parabolic line, and this parabolic line, when you take small intervals, and that's going to give a line which is going back to 0 on v versus t. Slope of this line t is going to be a positive line on a versus positive line like this. So far we have covered 7 type of possible motions. This one is speeding up to the positive direction, and this one is speeding up to the negative direction, and their corresponding velocity versus lines are, and acceleration versus lines are marked accordingly in red. The next is slowing down to the positive direction, and now slowing down to the negative direction, slowing down to positive direction, slowing down to negative direction. Corresponding velocity and acceleration lines of this motion are also shown accordingly. During this speeding up and slowing down processes, there are constant speed regions, like this one is keeping the constant speed while the vehicle is moving to the positive direction, home to college. And this is now college to home, or to the negative direction. During this time, constant speed region, corresponding v versus and a versus t graphs are also shown. On v versus t, constant line like that, and a versus t, it's 0. Next is no motion region. That means coordinates are not changing, so v versus t has to be 0 as marked, and a versus t also 0 because no motion. Let's summarize. How did we go from x versus t to v versus t, and v versus t to a versus t? X versus t to v versus t, we calculated the slope by simply taking smaller intervals like that, and then marking the slope of these smaller intervals. Okay. And then that was just simply an increasing line, linearly increasing line, showed on v versus t graph. Slope of this line on v versus t, regardless of the interval you take, is a single number, can be just simply marked as constant value. V versus t to a versus t is another slope calculation. So let's mark that as a. Now next is how to go from a versus t to v versus t backward. For that, area is the solution. Area is the answer. That means we are calculating the area of this line, and we find that it is a times t. This a times t is going to be marked on v versus t as shown, a times t. Now if we continue the same direction, applying the same rule, now we go from v versus t to a versus t. We do another area calculation. That's going to give us 1/2 a t square, and now it's going to be marked on x versus t as 1/2 a t square. Okay, so we can also name them as 1 to 7. 1, 2, 3, 4, 5, 6, and 7. 1 and 7 are positive acceleration as shown here. That means positive speeding up to the positive direction is positive acceleration, while 7 slowing down to negative direction, also positive acceleration. So 1 and 7 are all positive accelerations. And how about 3 and 5? 3 is slowing down to positive direction, while 5 speeding up to negative direction. Negative, they are marked as negative acceleration and negative x.